Now, reflection and absorption by a layer of the atmosphere. Through the conservation of energy. Energy cannot be created or destroyed. It can only change form. The conservation of energy requires that for radiation incident that comes from the sun on a layer of aerosol or cloud is balanced by this equation. Basically, you just add this plus this plus this, you get 1, because this is a factor, let's say 0.3, 0.4, 0.3. If you add them all up, you get 1 because of the conservation of energy. Which means that the energy in the atmosphere that comes from the sun either gets absorbed, either gets reflected, or gets transmitted. So the fraction that is absorbed, the fraction that is reflected, that's a fraction of the transmissivity. When you add them all up, you get equal to 1. These are the three main mechanisms of energy change in the atmosphere: absorb, reflect, and transmit. Now, this extinction means the reduction is due to absorption and scattering. So that is a part of this absorptivity. Now, scattering may occur more than once and increase the path and the length of the path of the rays. It's not part here, but this one can actually affect absorptivity of the atmosphere. Because when you have scattering, then it increases the length, then increases the transmissivity of the layer as well. Because instead of going straight down, it gets and then scattered here, there, and so on. So the length becomes longer and the transmittivity becomes higher as well. So even though scattering is not part of this energy balance, but it does play a role in the absorptivity and also the transmissivity. So the volume extinction coefficient K lambda n sigma, they usually put it together as one parameter to simplify. That parameter is called the volume extinction coefficient. Consists of the scattering, the number of molecules, and the areal size of the particle. It is a measure of the overall importance of the particles in removing radiation from the incident beam. So the single scattering albedo, it is a measure of the relative importance of scattering and absorption. And this albedo is a factor from 0 to 1. So it's a range of 0.5 to 1, where at 0.5 it is non-absorbing and 1 is at strongly absorbing. And then there's also this asymmetry parameter. This asymmetry parameter is 0 for isotropic radiation. Now, isotropic radiation means radiation is happening at all angles, the same magnitude. It has a range of -1 if there's back scattering, +1 if forward scattering. So for aerosol, ice, crystal, cloud droplets, and so on, it's forward scattering, 0.5, 0.8, 0.85. And that's why we cannot see through it. We can see it visibly. We can see clouds, we can see ice, we can see the droplets, and so on, because of this fact, this forward scattering fact. Now, this asymmetry parameter, what does it mean? We go back to this. So this one means it is symmetry. It means from here to here, there's basically no scattering. But over here, there's high forward scattering. So this is for ice, cloud droplets, and so on. And that's why we visibly see it in the atmosphere. This value of 0.85 is that large scattering, the back scattering value.